Hi, I'm Aaron Ellis, Electrical Manager at Randazzo Heating, Cooling, and Electrical. Today we're in our shop. We got some noise in the background, so I apologize in advance, but we got some electrical questions from you, our customers, in regards to the electrical panels in your home, and they're going to be answered by me, your local master electrician. Question number one today is, what is an electrical panel and do I have one in my house? Well, if you're a homeowner, you have one of these. So starting outside, utility supplies power to your house through an electrical meter. Whether that's overhead or underground, that's dependent on the location that you're at. From your meter, it gets metered through reading the kilowatt hours, then feeds down into your outdoor either transfer switch or your outdoor electrical shutoff. From there, it is then travels into the house to your electrical panel. Your electrical panel could be either in a basement, in a garage, or somewhere in the house near an outside wall. So there's a lot of different names that these are known by, whether fuse box, switch box, breaker box, panel board, they all mean the same thing. It's your electrical panel. So with your panel, there's a lot of components to it. We're gonna go over those components today. Starting with the label on the inside of your panel. The label is gonna tell you the manufacturer, the ampacity of the panel, and how many breakers this panel can hold. Over here, we've got stickers on both sides. These are gonna be to identify the circuits in your home. So the electrician will write down what this breaker controls, and if he did a good job, then you shut that off, it's gonna shut off that circuit that you're looking for. At the top here is your main breaker. This is what controls the power to your entire panel. So with this being in the off position, everything below this point is all dead. Going into the panel, I've taken this one apart for you guys already, but inside the main components to your panel are your main breaker, which is where your feeds are gonna come into. From here, it is now fused at whatever ampacity this breaker is rated for, and then feeds down to your bus bars down through the back of your panel. These bus bars are interwoven together like little fingers coming down so that one leg hits the top one, skips one, goes to the third one, skips one, goes to the next one down. And then on the opposite side, it's interlocked between those. So if you have a 220 breaker, your two legs will be grabbed from the back fins right here. Now, when you take a voltmeter and you test from one leg to your neutral bar, you're gonna get 120 volts. Between any two legs, you should get 240 volts. Inside this panel also, you've got your neutral bars, which are these two bars on each side. Your feed will come in, your neutral will land here. This is connected through a bar underneath the bus to this side here. So these two are your neutral bars. And then on the side of the panel here, you've got a ground bar, which is isolated from the neutral bar and bonded to the frame of your panel, making the entire frame of the panel grounded. Something that's unique about your neutrals in your panel is it's isolated from your grounding. So there are actually two different systems inside this panel. I'm gonna flip over this, I already took it apart for you. And on the back side, you'll notice it's all plastic. The mounting bracket here is completely isolated from the steel of the panel. So that neutral is not in contact with it. Now, this ground is something that doesn't come from utility. That's something that an electrician provides for you. The way we provide that ground for you is through two electrodes. There's about 5 or 6 different types that we can utilize. The most common ones are 2 ground rods, cold water grounding, or rebar in your basement wall. Newer homes, you'll see a piece of steel sticking out. That's your rebar. That's the best form of grounding from your house. Now, we create that with a ground wire. We tie those systems all together, and then we bond it to your grounding here. The reason your ground is important is if you have a dead short in your wiring or a ground fault in your system, then you need a spot for that electricity to escape through. So the grounding is directly into the earth, and that allows that residual electricity to flow out to the earth and dissipate. Another question we get asked a lot is, what is the difference between a fuse and a breaker? So right here, I've got a breaker for you, which if you notice, it's got a little handle on it that you can flip on and off. This is a reset for the breaker. It's a way to shut the circuit down and to reset the circuit if it does trip. This, on the other hand, is a fuse. There is no handle mechanism to it. It's a one-time use device. Once this blows, it'll burn up the element inside of here. You unscrew it, you throw it away, you screw a new one back in. In the breaker world, there's multiple types of breakers as well. We've got a single pole, a double pole. This one is for a 110 circuit. This one is for a 220 circuit, similar to an AC or a range or a dryer. And then we've also got a GFI. They also make a arc fault breaker that looks very similar to this. Now, a GFI breaker is unique in the fact that it's sensing for a ground fault in the system. If you have a hair dryer, you're blow drying your hair, you drop that into a tub, it is now grounded out. Well, this is going to trip this breaker into an off position, saving your life and preventing a fire or any other kind of overheating. To reset a GFI, it's going to be already in the trip position. You're going to click it all the way to the off position and then back to the on position. In your panel, this will line up to where the off is towards the outside of the panel and then on is back towards the middle of the panel. With a GFI and an arc fault breaker, it's always wise to test these at least once a year. The way that you would test one of these is you press the button in on it. When this is energized, this is going to trip to a trip position. That identifies that it's working properly. You just reset it by shutting it all the way off and then clicking it back on. Arc fault works exactly the same as a GFI breaker. It's got a little test button on it. The difference between the two is instead of testing against a ground fault, it is testing against an arc fault. If you're not sure what an arc is, think about when you plug in a live light fixture and you see that little spark as it plugs in, that's an arc. So sometimes equipment, heavy duty equipment such as heating elements, things like that, when you go to plug them in, they're arcing. And what that does is it creates heat and it also creates a burning on the bus as it's being plugged in. So that arc fault is to prevent that from happening and overheating and causing a fire. And that'll trip just like a GFI, then you have to reset it and turn it back on. Now, a third device besides GFI and arc fault that is similar to an arc fault and a GFI is a dual element breaker. A dual element breaker, the only thing that's special about that is it's going to protect you from GFI and arc fault. So it's protecting you from two different elements. Another common question that we get is, I don't know what size my panel is. How do I find that out? So the easiest way to figure that out, I'm going to take the door of this panel, open it up, and if you notice on the label here, it's got the name brand of the panel, and then it's got tells you that it's an indoor load center, and then directly below that there's a serial number on it. In that serial number, the last 3 digits is 100. This panel here is a 100 amp panel. Another way to tell is if you look at the handle of your main breaker, on this one it's printed on both poles of this, 100 amp. So you know that this one is 100 amp. This box here is a 200 amp rated breaker, and it's easy to tell because in bold it says 200 amps right here. And the same thing, if you look at the serial number on it, you read through it, the last 3 digits are going to be 200, which identifies it as a 200. So we have a 100, a 150, and a 200 are the most common panels in a home. Another thing to note is on this box here, on our sticker, it says outdoor circuit breaker. So this identifies this panel as being an outdoor rated box for a service. This one here is basically, as it is identified here, an emergency disconnect for the outside of your home. So to answer the question of how a circuit breaker works is when you look at the breaker itself, you've got a little handle on the top of it. This would be on because this would be facing towards the middle of your panel. This would be off. If a circuit has a overcurrent use or a short of some sort, then what's going to happen is this breaker is going to go from the on position to a middle position. The easiest way to tell if your circuit is tripped, in your panel, run your finger along the breakers. You'll feel that one of them is just slightly out of line with the others. That is a trip breaker. Now, the best way to reset a breaker is don't just flip it back on. It's not going to go on because it's in a trip position. You're going to have to reset it. So you click it all the way towards the outside, which resets the mechanisms internally, and then it will turn back on. Now, before you turn that circuit back on, my recommendation would be unplug everything that's plugged into that circuit that's off, make sure your light switches are off, and then try to reset it. If it does not reset, that tells us that there's something in the wiring system that is faulted. At that point, contact an electrician like myself or anybody in your local area. Now, if your breaker resets with everything unplugged, then we know that it's something to do with the appliances that were plugged into it. So one at a time, plug them in. If you sense it trip again, you know that that's the appliance that is the problem. And again, you can contact a professional that knows how to work on those appliances to have that repaired. Now, a lot of times you want to know what something controls in your house because you may want to work on it and you want to shut that power off before you do so. The best way to find that out is look at your panel legend. I'm going to open up this panel here. You can see in the panel, we've got our legend. Sometimes it's listed out here. There'll be lines just like this where the electrician will fill out the information here. Other times it's listed here. Now, across from each breaker, it's going to have the identification of what that circuit controls, if the electrician did their job properly. If not, you're going to have to go through, plug something in, flip breakers off until you find that circuit. Now, even when this is identified as controlling something in your house, I would say use that as a reference point only. Don't use that as law. Sometimes breakers get jumbled around, things are added to a panel, and they don't relabel it. So flip it off, test it with a tester. There's many different testers out there. There's plug-in testers, there's tick testers, and there's voltmeters. Make sure you're using the right meter to test it to make sure it's dead before you start to work on it. Another cool thing about panels is all these breakers could be different sizes and they all mean something. Why they are different sizes? These ones here, I have a 15 amp, down here I have a 20 amp, over here I have a 2-pole 30 amp. In your home, your lighting and plug usage is generally 15 amp rated. So 15 amp breaker, 15 amp circuit. The appliances in your kitchen, your laundry, and your bathroom usually require a little bit more current, so they require a 20 amp circuit. Your 220 appliances, such as a dryer, requires a 30 amp, a cooktop would require a 30 amp, a range would require a 50 amp, and an AC, depending on the size of the unit, varies from 20 amps all the way up to 50 amps. Another load that you might have in your panel would be an EV charger. Now, an EV charger draws a lot more power than anything else in your house does. So a lot of times, if it's hardwired, it's going to be on a 60 amp breaker. If it's a plug-in, it's going to be a 50 amp. We at Randazzo do install those. So if you have questions or need one installed, give us a call. As of March 12th of last year, 2024, the National Electrical Code was updated. One of the new updates in the National Electrical Code was having an emergency disconnect on the outside of your house. This is a typical 200 amp. What you would see is your meter would be mounted on the outside. The wire would come down into either this one is a generator transfer switch, but it's a main breaker. So this would be your emergency switch, or you would have something similar to this outside. Now, the reason this is important is if you have a fire in your home and the fire department comes, before they start spraying water on the house, they want to be able to shut off the power inside so that they don't get injured outside. So the shut off kills the power to the house, they can go and do their work and they're safe. If you liked what you saw today, please like us and subscribe. That's the way that we know that our information was important to you and we can put together more of these videos for you in the future. And remember, for all your electrical, heating, and cooling needs, go with the name you know. I'm Aaron Ellis, and I'm Randazzo Heating, Cooling, and Electrical's Electrical Manager.
Go with the name you know.